So let's take a look at what that code might actually look like. Okay. You can see here, I've got the same list here, or a similar one. Actually, I think I added some more crap in here, playing around with it earlier. That one actually goes down to the E level. But I've got a function called count leaf items. First thing I do is it prints the list that it's given as an argument. Prints it, and the count is set at 0 for here. For each item in that list, it says if it is a list, then print I encountered a sublist. And then you are adding to the count. Here it is, the recursion, count the result of count leaf items. So each time this runs, as it completes running, it passes the count back up to the main list, or back up to the whatever's above it. So when I was talking about this, as it finishes a list, right, then it's going to go back up to the one before it. This is, every time you see an arrow pointing up, it's passing that count back up to the list before it, and it gets grouped with what it's counted so far at this level. Okay? And it does this all by itself because what's happening here is, if you think about the fractal, how it's a design within a design within a design, this is actually running a function inside a function inside a function. And as those smaller functions complete, they're passing their information back up to this variable where it gets added. So this main function runs only one time. And then it spawns all these sub functions. Now you can actually have dozens and dozens of levels going on in Python all at the same time. And as long as they close and wrap up neatly, Python does not have a problem. Okay, so if it's a list, for each item in that list, if it's a list, we recurse. If it's not a list, then we just count it. We count that leaf item, we print it out, we say we counted Bob or whatever. We add 1 to the count, and that's it. So it's going through that list all the way through. And when it's done going through that list, we're passing it back up to the main count. So when it finishes the list, it says returning count X. That's how many items I counted in that list. It returns it, which means it goes back into here and works its way back up. Okay, that's the whole program. And this program is able to count the number of string items in any number of any kind, any shape of nested lists. So let's run this. And it goes very quickly. But look at this, we can see. Okay, so here's the first list. We give it the main list when it is first called. It says counts leaf item atom. So the count at the main level is 1. Okay, now here's a sublist. The sublist is the B and under. So it's the second item in the main list. It counts Bob. The count at that level is 1. Now remember, the count at the main level is 1. The count at the second level is 1. That's where this gets a little bit mind-bending. And then look, it encounters another sublist. So we do this. We count Chet. Third level is 1. And then it encounters another sublist. We go on like this. Okay. We count Doug. We count Dave. At this level, the count is 2. Encountered a sublist. And this is the lowest level list, right? We have Evan, Egbert, Eagle. counted those through, 1 through 3, and now it's returning the count of 5 or 3. Now, if you remember, the D list had a count of 2. That gets added to it and returns. The B list or the C list had a count of 1. So that gets added. And then we're back at the B level. If we look, we've got Barb and Bert. So we're counting Barb and Bert. The count is 9. And now we're returning that back up to the A level, which is now 11. Because we count Alex, right? So Alex is right here. And then we've got one more sublist that adds 2 more. So we go back down that level. Barb and Bert, or sorry, B and Bill. Count 1, 2. Then it returns those 2, counts Ann, which is the last item, and there's a count of 14. So it makes quick work of this, and I can even, if I want to, I can add another list here. And they don't have to be unique names, so I'll just copy. So I'll add 5 more in a sublist at the very end here. And it does not matter, it does not care. As long as these lists are properly nested, it will just zip right through them. And it will follow any structure that conforms to nested lists. So if it has a list inside a list, it will follow that structure. And the cool thing about that is because when we encounter data like 100 million web pages like ChatGPT makes sense of when they're training the GPT models, it's basically looking at a world of information. It doesn't conform to a specific shape or size or expectation. It's just whatever's out there. So you have to have these things, these algorithms that can take something that's unpredictable and make sense of it. And that's one of the reasons why recursion is important out there in the real world, even though it's kind of a little bit crazy to play around with. So